I have no idea where my hair tie went. So I guess my hair's just gonna poke my eyeballs. Poke my eyeballs. So going back to yesterday, I was stuck with this, right? So I was stuck with this thing over here. Man, the weather's very bad today. I'm gonna look for my hair tie. Here, come. Come here. Cool. What's this? Really can't find my hair tie. Oh, it's just here. What the heck? I don't see it. So I believe I have to do something similar. It's just that I had a hard time visualizing what this was. So I asked the Haskell Discord, or rather the functional programming Discord. And yeah, so basically what I asked was, and and I annoyed some people over there, so I feel bad, but I don't care. As long as I had my question answered, then should be fine. So basically my question was for this. So if I, in yesterday's example with implementing an fmap for a tree, or rather implementing the functor type class for the tree data type that we created. So a tree data type that we created was something like this. I feel like it's a bit too thick. How do I change the brush size? I mean, is that something I can change? Like the default size. I guess not. Oh wait, yeah, I can. Oh yeah, okay. So what I asked was, if I have a data tree A is equal to empty, so this is if it is empty, and oh wait, sorry. So and then we have node A, so it has the same type as this type variable. And then we have here for the left side, so for the left child, and for the right child. So essentially these are subtrees, or the children where they're trees as well. And so there was this functor or fmap implementation where we have an fmap where we have the function over here, and we have node x, then left and right. So we create a new node, or we're going to update the value of x with this function here. And what we did was something like this. So fmap f left and fmap f right. So we performed the recursion, I guess on this side and this side. So this will update all of the values, all of the node values in this subtree and then in this subtree as well. So overall it updates every single thing in a tree. So my question was, if I run this, how or in what order will this be quote unquote evaluated? And they didn't like that term. So I'm not so sure what I'm supposed to call it. I don't know what I'm supposed to call it, but yeah, they didn't like that term. So they responded with the order in which this is evaluated would depend on how this is being consumed, or on the consumer. So how I imagined it was, if I had, or if somehow I want this to be evaluated first, then this is gonna go first over this, or maybe it can be left. It can start with the left side, or it can start with here first. You know, those kinds of things. So fmap doesn't particularly care which order. It just does the thing. It just shows you what the answer looks like, or that's what they said. I don't completely get it yet, but yeah, something like that. So then if I go over here, wait, hold on. So let's say this gets evaluated after this. So this gets evaluated, This is gonna result in the first recursion. This is gonna result in node. Let's just say we have a tree here that is, or this is how I pictured it. I could be wrong. So let's say I have a tree over here. We have 1, 2, 3, and 4. So this is going to be empty. This is going to be a dead end over there. So if it's like this, how I imagine it is that we have, so our value over here is going to be 1. So let's say that the function of f, let's say f, I don't know where to put this, but I'll just say that, let's say f of a is equal to a plus 1. So let's say this is what the function does that gets passed to fmap. So we're just going to update the node values by 1. So if that's the case, then this is going to be 2. And we're going to have something like, if I'm not mistaken, it's like this. So this, and then f, right. So we perform the recursion over here. This is going to be node 2. And over here, we're going to have node 3. And then since we have a child over here, we're going to say that this is going to be an fmap. Oh, whoopsies. It's going to be something like this. And then same thing with this. So f. And then we're going to leave this alone, I would say. So this is now going to be the left child, and then this is going to be the right child. Yeah, so something like that. So now it's something like this. And if I were to go one more recursion and stuff, so one level down, we're gonna have like something like this. So this is gonna be like a left associative thing. I think could be wrong here. I'll be back to watch in a sec. Hey, Cosmic. No worries, bud. If I do something like this, it'll be node 2, node 3. And then since node 3, so we have node 4. And then node 4, it's empty. Both empty. So we'll do empty. But we don't know that yet. So this is going to be an F left. And F right. So this is for the left part. So this is just for the left part. Okay, this is pretty long now. Of that one, we still need another one over here, which is node, which is going to be empty. So this is empty. Actually, it's not that long. Yep. Yeah, okay. have no idea what. Oh, okay, yeah. I guess I got stuff to do still. So now it becomes like this. So this is the left child of this node over here. So left over here. Oh, wait 1 sec. So node this over here. Yep. So this is going to be the left. Oh, I wonder how I can shift here. So left, and then the right, because the right child of this is empty. So it's gonna be something like that. And then we can go over here. This will be evaluated. Or I guess not, huh? I guess not yet. So it's just gonna stay at. Wait, so that means this won't be empty. Hold on. Wait, that means this won't be empty then. This will just be fmap until all of these are like empty, and then yeah, cause we're still at this, right? So we're just gonna write down the other things, like 1 2 1 2. Oh, this one's for this one though. So here, and then this would be. I wonder if it's like this. Might have missed something. So it'll be like that. Then in the next one, it's gonna be empty, and then that's done. So then empty, and I guess it would evaluate the rest of the stuff. I wonder if this is. So if I use a list, if I were to turn this into a list, then I would need something to first convert it into a list. But for sure the function has to have an append. We need an append, and we need recursion. So append, I guess, would be something like, we'll take a tree in. Because what I want to do is, so my strategy will be, I have to pick out head, and I have to pick out the node value. So node value is going to be over here. I'll do something like cons, and then this is going to be the node value. So I don't think, no, append shouldn't do this. This should be list. And this will be the tree to list. So tree to list is gonna have tree and then list. So it's gonna return a list. I know. So it's gonna take a tree where we say node X. So that's the node value. We'll just do L and R is equal to, we can maybe do something like const X, and we can do something like an append. So we will append these two together. So we have const. Oh no, sorry. We have an append for left and right, but then we have to call. We have to perform a recursion here. So there's gonna be tree to list. Tree to list on left over here, and then tree to list on right. So R. So something like this. I think something like this would work. Maybe. Not sure. So if I'm not mistaken, maybe this would work fine. Because I'm appending the left and right while attaching head. So let me see if this would work. So for something like this to work, I'm just gonna draw the tree again. For example, I'm gonna have a tree over here with 1, 2, and 3. Let's say over here is 4. And then the rest of the stuff is pretty much a dead end. So dead end over here, dead end over here, and dead end over here. So let's say it's something like this. How this tree to list would work, I wonder if it's correct. The expected output should be 1, 2, 3, and a list. In a list, I'll just mark this. So this should result in this over here. So over here. So this should turn into a list of 1, 2, 3, and 4. So it should be a list of this. So I should do the leftmost first and then try to see if we can have any. So that means if we put 4 here and then 5 here, it should be 4. 1, 2, 3, 4, and then 5 there. If I do something like that, I wonder if this would work. So we're gonna try this out. So if that's the case, we'll write the process in purple. So first, we're gonna start with 1. So we have node 1, where this gets turned into a const. So const 1, and then now we have this over here. So we have append on tree to list over here. So we're just gonna say that this is tree to list. So tree to list L over here, and then this is a tree to list R. So this is what happens in the first recursion. And so now let's say it's left dissociative. So if it's left, if it's left, oh, what does this do? What does this button do? Enter full screen mode? Whoa, cool. Oh, this is super cool. I've been looking for something like this. My paint's pretty cool. So if this is the case, then in the second one, I guess I'm gonna evaluate this over here if I wanted to. Let's say it's left associative. So this is going to be cons 1 and blah, 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 append. So let's just say append. So let's treat the list of this, right? So it's going to be a cons. And then on this left side is a 2. So do a 2. I'll just make this short. I'll just say the function is okay, let's just say it's a. So let's say the append is a. So if this is the case, and then if I have a tree over here, so tree to list is going to be L, and then this is going to be tree to list right. Yeah, so that's how it's going to be. So one. Oh god, I'm so confused with the parentheses. So something like this. And we'll have a tree to list R. Something like that. So we have a 2 over there. I'll just probably remove the cons and stuff. I'll just say, so for the third one it's gonna be 1. And then 2. And then down here, wait, sorry. 2, then no, we still have to append. I'll just say append. This would be 2. And then append. Oh, this gets confusing really fast, huh? So the left of this is going to be 3. And then it's gonna be nothing. So, oh god, I'm already lost. Okay, I now see why it got super confusing. Maybe it would be better to visualize it rather than write the thing down. Yeah, I'll try something like that. Okay, how do I erase this? Draw rounded shapes. Oh. Bam. Okay, I have no idea what that just did. What happened to these icons? Pan, view, flip, switch between. Maybe I'll just. Whoa, what happened? So I'll use the eraser instead, and I'll just increase this. How do I change the... Sorry, what? I don't know how to use this. Maybe I'll just move this instead. Okay, new thing. I'm just gonna draw the thing over here. So let's say 1. I'll convert this into a thing over here. So 3, 4. So I start off in the first thing over here. How the list is gonna look like is, but can I really do something? Can I really visualize this? I mean, it got super nesty really fast, so it's kind of what I'm struggling with. I mean, it feels correct. What if I'll do it for a smaller subtree instead? So let's say this, or even just this over here. Yeah, let's just say this part. Let's just say I'm doing this part. So tree to list gives back a list. Tree to list also gives back a list because of this signature over here, where it takes a tree and then converts it, or returns a list. So I think this would work, but I want to prove it. How do I prove this? Because it's just so messy. I guess I could just write my append function like this. I feel like this is going to be the easy part. So I'll say append. I'll just use the same thing I did earlier, where I take A and B, or I can even do something like but since we're using a custom list type, we're going to do something like cons A's, and then B's. So this will be our first thing. And we're just gonna put it into a cons over here. We do cons A, and then we'll call append on A's and B's. So from here we can say that the append, when this reaches empty, because we assume that we already have the list here. So this is gonna be an empty, and we have B's. We're just going to return B's. So by the end of this, we're just going to chuck that right there. So just in case. Yeah, okay. So once we hit empty, we're gonna put that there. Yeah. So I think this would work, because we recurse through this. This gets converted into a list by the time it pops back up. So then we can assume that this is a list, and same story with this. After that we can append it, and we have the cons over there. So let's see if it works, but I don't know though. I'm just monkey braining it. So we're gonna write an append over here. We'll just say append. Maybe it would help if I just, write. I mean, it's the same thing. So we'll do something like cons A, and then we'll do a recursion here, which is going to be append A's and B's. And if this is empty, and B's, we're just gonna do like something like this. And then we have an append over here with the type list and type signature of. So list A, list A, list A. So something like this. Then we can just say that this is going to be const x, and we'll do go, and then maybe I can do something like this. Go tree to list, left, tree to list right. So something like this, maybe. Sorry, it's not go, it's append. So I think that worked. I messed up my sleep schedule again. Ah, buddy. Rip. Yeah, it's actually kind of hard to fix it. What I usually do is I would do it. I would kind of adjust it per hour. So let's say I sleep every day at like something crazy like 3 a.m. in the morning. So what I would do is I would try to sleep 2 the next day, and then I can try to get used to that, and then a few days after I do it another hour earlier, so like 1, and all the way until when it's normal. Because the problem with if you do it really drastically, where from 3 and all the way back to 10 all of a sudden, that's going to be very hard to keep up, because your body's just not going to get used to it. That's kind of what I struggled with while I was still in undergrad. It was I had to keep fixing my sleeping schedule. So I'll try something like this. Tree to list. So I have T over here. A node, let's say 1. I have sleep anxiety, so it's hard to sleep sometimes. Have you tried consulting checking with a doctor and then asking if they could prescribe melatonin? That's usually what people use to help them sleep better, but it depends. I think that has to be prescribed, if I'm not mistaken, by your doctor. So yeah, I hope you can fall asleep though. So that's if we do something like this. So 1 node has a value of 1, and then 2, and then 3 all the way here, and then there's none for that, so it's gonna be an empty tree. It's gonna be empty tree as well for this node, because 3 has no. I have melatonin. Oh, so that doesn't help, or you don't like taking it, or how does it work for you? So we have this. 3 has no siblings, and 2 has no not siblings. 2 has no right child, so this is gonna be an empty tree, right? So something like that. And for this side, we're gonna have node 4, and this is gonna be empty tree and empty tree, right? So now we have. It's a natural drug, so it doesn't need to be prescribed since your brain makes it for you. Yeah, I guess. Well, that's true, yeah. It's a chemical that your brain already produces. But I usually want to check with a doctor so that, hey, are there any things that I have to be aware of when taking this, you know? But if you already have it, I mean, you can try taking it and see if that helps. So if I do tree to list on this over here, we have something like this where it says non-exhaustive pattern. So it seems like it's working. So we have 1, 2, 3. And the only thing that we have to take into account is when it is an empty tree. So when it is going to be empty, so we have this. Over here, hold on, we're almost done with this. So once we hit an empty tree or something, yes, so once we hit an empty tree, we're just gonna say empty. I think this would work. So we have to reinitialize that and tree over here. So now we have a list where it's const 1, 2, 3, 4. So it works. We're just gonna adjust our code a little bit. I had the time to just think about it, to just sleep on this, so that's why it just seems like a no-brainer now. So yes, it works. Okay, wait, let me read. It makes your brain produce more melatonin, but since I can't get calm enough to produce melatonin is weird. And I don't think it works on me. I took it for 3 years and at one point it just stopped working. Maybe your body just got so used to it that it stopped producing melatonin altogether. And now the melatonin isn't enough. So you have to take more and stuff. I don't know though. I had a doctor, so yeah, don't take it from me, but I have no idea why. I ain't a doctor. But that kind of sucks though. I guess you're just gonna have to try to, you know, try working on your sleep, man. An hour earlier. It's gonna be hard, like really hard. At one point it just took me like a month to bring my sleep schedule back to normal. It's so hard. And it's so easy to just break it. Like right now it's broken, so I have to try again. I think it was in fmap. Or was it? Yes, I'm pretty sure it was in fmap for a list. Oh no, it was over here. That was a super weird lizard, dude. I don't know if you can hear it, but there's like a big lizard making sounds. So we can just use append here, rather than using the go helper, because we already have this. So you have something like this. We have const append. So we're just gonna see if this one works. Wait, hold on, Cosmic. Let me use my remaining brain cells for this. So we have this, right? We're gonna try +1, and applicative. So we'll do something like this, and then we'll do this on a list. So we'll do const 1 and then const 2, empty, empty, something like this. And it says here that we have a problem. Oh boy. Wait, hold on. Komodo hype. So I wonder why this won't work. Const fs. Oh, the doy. I'm so stupid. Oh my goodness. I'm actually so stupid. Whoops. Whoopsies. Whoops. So we have something like this. This is gonna be empty. So this is gonna be const +1, and then we have empty. Applicative on, so apply these over here, so const 1 and then this. So I guess this has to be, wait a minute, let me look at the list type again. Right, so should be something like this, yeah? Oh. Okay, yeah, there we go. I added one too many empties. So this applies these arguments over to the +1. So we do +1, so it's const 2, const 3, and then now the last thing over there. So if I want to do something like this, if I want to change stuff, so I'll do like something like a const over here, and then I'll say this is empty. So I guess I can just remove this. Wait, aren't Komodos poisonous? Yes. Komodo dragons are poisonous or venomous. I don't know which. I forgot how to use the term properly. But I feel like I'm not. So if I were to put another thing, it would have to be something like this. So similarly, we should have something like this. And if I want another thing inside here, I'll do something like this. And obviously, I have to put empty over here. So that marks the last part of the list. And something like that, obviously. So then const 3, and then this is empty. So there we go. So we have 2, 3, 4, and then 2, 4, 6. So I think this one does it properly. Yeah, we did it. Amazing. Hooray. Complete chapter 4. I did it. We did it. You have a lizard? Yeah. We just let them lizards. We just leave them alone. But you know those kinds of house lizards and stuff. We don't really bother them. They don't bother us. It's not like we're gonna be put at risk if they're around, right? In fact, they are doing us a favor by killing the bugs and stuff. So just just chill in the house, mind your own business, mind my own business. Then we good. I want to play a game since it's already late to sleep. Modern Warfare or Overwatch, you choose. I guess Overwatch, cause Modern Warfare is no good for you. You can play Overwatch if you want. I feel like you'll be less angry, maybe. Who knows? So I feel like we can submit this already. So you can open a pull request for this. Maybe the next thing I will do is or something like that. But yeah, here we go. We're going to open a pull request over here. Chapter 4 solution. Cannot automatically merge. Solutions for chapter number. So I wonder what the conflict is. I guess I gotta rename this. So chapter 4. And I feel like, yeah, I changed 2 files. Yep. So we'll compare the thingies. I'm gonna have to just I'm just gonna copy the template for chapter 3 so that I won't have so many files. Welcome to chapter 3, Courageous Knight. So chapter 3, we're gonna reset this back. We're gonna remove our answers. Reset chapter 3. I hit 3%. Most kills in Modern Warfare was pretty poggies. Ooh, 3%. Cool. Do I think is my internet dead? Hello? Dang it. I don't think it's dead. I don't know what's wrong though. Okay, so it seems fine. So I guess we're done with this. We're done with everything. What do we do now? Additional resources, deriving, and extensions. So these are the things that I have to try to read about. Deriving, I sort of get it. Where you want to extend a type. I know it very vaguely. Oh, good lord, what happened here? Oh. To answer the question if I play Fortnite, I don't play Fortnite. Okay, now what should I do? Um, I'm done with the thing. I'm pretty happy with my solution. It took some drawing to figure it out though. Sorry if I don't type much. I'm cooking and you know, hey bud, it's cool, it's cool. I mean, just leaving this as some background thing is pretty good already. And I'm really thankful that you could do that. I don't want to burn the house down. Yeah, man. Now would be a really bad time to burn your house down. Well, any time is a bad time to burn your house down, but now especially is an extremely bad thing. So yeah, go focus, man. Just you can just leave this on the background. No worries. No problemo. But yeah, this one helped me understand. I had to just write everything down. I was like, huh, would this work? I just wanted to know how Haskell processes these kinds of things. So I tried asking it in Discord, but they got annoyed that they had to explain something so obvious and that I used some terms wrong, but yeah. So I think it's fine. I guess I can just delete this now. Goodbye. Goodbye, drawings. So off to the next thing. The next thing being... I can't find the thing that gauges temp. Oh no. Hello, undercooked food. Or overcooked. I don't know, whichever, you know. Whichever. The thing that I want to try next is type classes. So something like this, because they have monoids and some other things that weren't really included in Koenig's Learn for Haskell. Obviously, because it's just 4 pull requests. There's only so much you can cram into that. And so we're going to try this out. This over here. I'm just going to read because I don't think I can play videos. Oh, hey, Blups. I see you lurking. I see you lurking in chat. So types are like sets. So integer type is a set of integers, natural set of natural numbers. Rational, sorry, set of rational numbers. Cool. So we can think of types as sets when you think of it. Are useful for different things. Cool. So they treat types as sets or something like that. Now let's go. The concept of being a number is represented through a type class. We have types in Haskell, which are like sets, and we have classes. Maybe I should update my Twitter so we'll have an idea what we're doing. Nah, maybe not. See. Oh, I didn't put one for Twitter. Should I put my Twitter thing there though? I mean, I can do that right now. For my socials. Let me try stream. Hold on, let me change that. Cloudbot. Commands. So I guess I'll just add my Twitter here. Command at Twitter. I think I should have it now. At Twitter. There we go. I believe that is my profile. Yep, it is my profile. Oh wow, Cosmic, you found me pretty fast. Yeah, you have a nice voice and you can whistle. You're perfect. Thanks, Cosmic. But I feel like you could always, you know, train the whistling part. Maybe I should do Advent of Code. Advent of Code 2020. But I also want to do this. I'm just torn. Calling type class num includes a bunch of types. Bunch of types of numbers, including integer, natural, rational, and some other types of numbers, and it gives operations that have sets that include actual values like 1, 2, 3. Those sets are integers. Okay. We have a type class that tells us what all of these types have in common, the operations we can do with them. Yeah, I understand that. I'll just load this so I can read this later. Mental picture of what defining a function looks like. So drawing a line from things on the left to things on the right. So the numerical form of the number into word. So it's like a function that is from number to string. Or something like that. Keep this notion in mind. A function is the process by which we match up the column on the left of the column, I think. Okay, so yeah, we have a spell, so there's the spell thing. Spell function, yep. Okay, I pretty know this part. And then we have basic types, yep. So this is a sum type. So a sum type has like alternatives. So a boolean is can be true or false. So it's either false or true, but it can't be both, because that would be a different one. That's not a sum type. Oh wow, cool, Anyway. Yep. 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 Okay. I got it. Okay, so types and functions continued. It talks about some type classes over here, like the ord class. So we have an expression over here. If x is less than 10, then we negate x. Otherwise, we add 10. So that's pretty self-explanatory. So what type of a number? So constrained polymorphism, we don't know what the type is, and we don't need to know. We have a polymorphic expression. Can take two different types. Yep. So we have I don't know. And this thing over here. Yep. Because it can just be anything that is a number. That includes natural, rational, all those kinds of numbers. So we have a variable named, okay, yep. The OR class, so the negate and plus functions come from the num type class. Yep. But the lesser than function comes from a different class called ord. So anything that can be ordered over here. And these are the functions that gets implemented, so we can try to compare it. So if we compare two things, it should give us an ordering, which is less than or greater than or equal. And we have these common operators over here, which is the less than or equal, and then all these things. Yep. Yep. So yep. Okay. I saw this LM function briefly before. Tried to write a type declaration for the preferred J. First think through what types of all sub-expressions must be. What is the type of LM JX? What are the types of X and Y? Then finally, what is the type of preferred J? So okay, let's try this. So first LM. Oh wait, that's not the elixir. Hold on. Whoops. So TLM, we have a foldable. So T implies that it is a foldable. And A implies that it is an equivalent. And then, yeah, so, okay. And if I'm not mistaken, we have, okay, so we have something that takes a kind of this, so something like a list or a maybe, and then constraint over here. So does that mean I can do something like a LM true in, oh, maybe tomorrow the new Overwatch event. I can't wait. Oh, it's already tomorrow. Cool. So that means I can do something like this also, because it has the same kind. So I can do just true. I can also do nothing over here. So it could not match. Oh, right. So that's maybe cool. Why did I think of that? So we're trying to see if the value that this maybe context holds is true. In this case, it's not. So, okay. So it's asking what is the type of LMJX. I don't really know what type of the result of this. It's a boolean. And what are the types of x and y? So x is going to be a string, and y is going to be a string. And then finally, what is the type of preferred j? String. So this type signature is gonna be, wait. Maybe this is gonna be, wait, this is not? What I'm thinking is just string, 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 because it takes in, so something like, then maybe I can use ord. Yeah, I can use ord. So maybe it's something like this. And if I want to make it polymorphic, I can just do something like this. But then since this is a string over here, oh no, a character, so this has to be, oh wait, no, this can, I think it can do something like this also. If we do lm and then j, wait, let me just move it over here. If I do lm and j, and then I'll just say just j, that's gonna work. So it doesn't necessarily have to be a string. So x is really just implies foldable. So it's a foldable then. And if that's the case, we're not necessarily finding an order here. So maybe it's more like foldable. X and Y are going to, so something like, maybe the Overwatch event is tomorrow. You can't wait. So I'm going to watch my show and eat food in your show. I'm just gonna do a bit more studying here. Buada? What's buada? Buada. Wait, is Buada the ballad guy? That was the monk. That was a monk? Really? I don't get that reference. See you around, Cosmic. If ever you get bored, I'll just be here for another 3 hours. Yeah, another 3 hours. Ballad guy? Bald? Oh, you mean, I'm not sure. I don't really know monks and stuff. I don't know if that's from a movie or anything. So that means this has to be anything that is foldable. So if we try that out, you can try making a new project, I guess. So you can do something like this, then we'll do main.hs. So we'll just put it on main. So then we'll move this over to the right, and we'll split this so that we don't we don't, we don't do the watermark thing. So GHCI main not HS. This is gonna be for practice. So we can do something like prefer J. I'm thinking that it's a foldable. So A and prefer J over here is going to be X and Y. And the thing was if LM J in X, then X else Y. So this one, it has a suggestion. It's saying why not JLMX. Alright, HLint. Alrighty. So I'll do something like that. It's saying that it requires more argument to A, but has kind. Oh, I mean, duh. Oh my god, duh. So maybe not this, huh? Yeah, how do I do something like this? So I need. Got it. I was thinking Buddha. Oh, okay. Okay, that makes sense. I wonder if I can. Alright, see ya, Cosmic. I mean, why is that not allowed? So expected one more argument A. Apparently it's like that. But seems like it doesn't work. ATA. I guess because I need this. Yeah. So if I check what foldable is, foldable. So foldable has this kind. Meanwhile, if I do K ORed, it has just that. That's why this only requires this. But then in this case, I'm lacking this over here. So T and A. So interesting. Interesting. I have to practice more with these types. So equals equivalent ATA bool. Everything is TA here. Let's read more about foldable. So they're saying that rather than this. One matching type. So in line 2, one matching types this expected TU car. Second argument, namely of LM, namely X. I have to read more about foldable. I feel like I'm missing something obvious. Dove, star, arrow, star. So star, arrow, star. this is just right. In this case, it's T car. That was obvious. Because what I did earlier had a kind of star, because this is not implemented. I mean, this is not, this wasn't given anything, so I have to, dang it. I'm not too familiar with it yet. Wait, what was this? Foldable T car. Oh, it's the T that's foldable. Huh. Okay, wait. I'm getting schooled every day. So T. Oh, this is. I have to read more about constraints. I wonder if they talk about constraints more. Over here. Oh, because this is the context. So you're saying that this context is foldable. Anything that implements the foldable type class, it doesn't really care about whatever we pass here, just as long as the context is a foldable. In this case, it is num a over here because we care that yeah, we want this value over here to make sure that it is oh god, that it's a num, and that's why. So something like that. Yeah, saying foldable T and then T car. That's because it can be a maybe car or a list car, or I don't know, an either int, like a T either int, then something like that. I don't know. So it has to be either has to be partially applied. It can be yeah, anything that has a kind of this, or in this case that, and a constraint. This part I'm not too familiar with yet. Why it ends up in a constraint. A constraint, whatever. Yeah, that's for the preferred J. So that means the type of LMJX over here. Maybe it's asking for a type signature. So there's gonna be like a car and stuff, and return say bool, because now we have something more concrete. And what are the types of X and Y? It's going to be anything car. And then finally, what is the type of preferred J? And we've just done that, so it's a foldable. Any context that implements foldable, and then a car because of J over here. So branching generalized, we'll take a look at the case keyword. Let's go back to the conditional statements. Yep. So I don't, lizard. Very loud lizard. This one just talks about cases. Then we have a maybe class. Or no, it's not a class, it's a type. So maybe we have a type constructor and then a type parameter. So this is the constructor parameter. Yep. Binding. And this uses dot binding. So we can say just Julie, it has a maybe string. Just 3 is going to be a anything that implies that it is a number. I pretty much know this already. So palindromes. Small interactive program. Inputs a palindrome. So if, okay, reverse. Anything that's a reverse and stuff. I think this is the thing that works towards. So we can try making our own. So checking if a word is a palindrome. No, word is a reserved keyword. No, it's a reserved. It's a function. So I'll do something like is palindrome. It's str. And then we can just check there's a reverse over here, which just reverses it. So reverse str. We can use an ETA reduce, but because we're still gonna add stuff to this eventually. Yes, palindrome will take in I guess this one's just reserved on strings. Yeah. So we want to reverse and check if this is equal over here. So we reverse the string and check if it's equal. So how do I check if the string is? Okay, I can just use this, right? Because it extends this, and we'll just have to check if this is equal. I wonder if I need to put this. So we'll do string and bool. Okay, it doesn't like the parentheses. So if we do something like this, we'll do as palindrome. Let's say taco cat. And that means it's a palindrome. If I put my name, it is false. So because it's not a palindrome, for this to be a keek. Okay, it's a palindrome. But if I have a capitalized letter, then it's false, even though technically it is. So I want to process this before we start the comparison. We can do something like a I'll try using a monad. What? If I were to use a monad here, I don't know though. I think it's just stupid if I use that here. So I'll just stick with this. So I have to lower, I think. Wait, where did to lower go? To lowercase Haskell. So I have to search Google for that. Google. Nope, not this. Nope, not this. I'll try lower. This has to be a function somewhere. Lower strength string. Parse car. Right? Wait, is this not? Is this just called lower? Not in scope, huh? What is this? So I have to import whatever that is? Man. Oh, there's a 2 lower there. I guess I can do that. So we have a string. Before we end up reversing this, we'll do a 2 lower. But this is a character though, so I have to map through the thing and manually convert this. So we have map. Then we have this function over here, which would be 2 lower, and on string over here. And this complains because cannot match type with, yeah, obviously. So yeah, then we have this, then we want to check if str is equal to this. Now I wonder what this cannot match expected type car bool with actual type bool. The first argument takes 1 argument. Hold on a minute, maybe I'm misusing this. So if I reverse this, yeah, I believe I was just misusing it. So if I do S palindrome on capitalized taco cat. Oh god, not that. Is palindrome. Wait, why is it still false? So map to lower. This converts it into that, and then we reverse it. Oh, because I didn't 2 lower this, duh. I think it would be better to do something like this. So a lower string, or we can even use a let, but I think this one's fine. So we're gonna do lower string, we'll do 2 lower str. And then we're just gonna map over here, so because this one only accepts a character, and so it evaluates character to this, and we want this to apply to the string, which is just a list of characters, so we can do something like this. So rather than doing something like this, we can do lowered str and lower str. So something like that, and we have an S palindrome, and now we have this. So it doesn't matter what case this is gonna be. So taco cat, it's always going to be true, because well, it is a palindrome. Okay, what's next here? That's the only thing I could think of. So experiment, we have this taco cat. Wait. Okay, so we have a monad. IL stands for input output, cool. So reading input, yep. Get line, yep. So we can just do something like a, you can just do something like main IO, then an empty tuple, whatever. So main is going to do this, and then do, We can say, well, whatever the string is, we'll do get line or read line, whatever the difference is. Seems like they used get line. Yeah, okay. So get line, and then we have is palindrome string. And I guess we have to convert this back, huh? Because it's expecting an IO. Now how do I do that? Do I have to wrap this in IO? Yeah, I have to wrap this in IO. So I have this thing called a print. Okay, okay. So I guess we can do something like this. I wonder if I can do pure. Wait, interesting. Print. So it does that and then into an IO, but can't I just do this? So it said cannot match bool with that expected type, and the actual type is IO bool. Oh, okay, maybe that's why. So it's, huh. I wonder how that was implemented. Haskell.org. You will search for print. So the signature says that it's show A, so A implies that it is show. Okay, so we have show over here where it converts anything to a string. Cool. So print over here. And the implementation. Wait, I want to see the source. Oh, okay. I guess I have to do something like this. So print, let's say put sterling, put string line show x. But I'm, oh, so I have to show first, and then this converts a string into that, into an IO. So I guess I have to put sterling. Put sterling, so I can't use that directly. Put sterling show is palindrome. Can I do something like this? Show is this palindrome is here. Can I do something like that? Or do I have to do something like this? It's gonna tell me to use print. I mean, yeah. But this can be right, because it's suggested correctly. So I'll say taco cat. So it's true. Oh, so that means this works as well. You can do something like print then, to make it easier. So if I call main, I'll say taco cat. So it should still say it's true. I like that I can check the source code for Haskell stuff here, just by searching in Google. So querying instances, we have info command gives. So the final type of main is IO. Yep, print can take some kinds of inputs and return printing to. Wait, there's still one more thing that I'm concerned with. It's the put string line. I wonder how that one is implemented. How does it convert that into just an IO, right? So we have the string here for sure. I don't know what this does. Dang it. Alright, I guess this some other time. Going down the rabbit hole. I don't want to go down the rabbit hole just yet. Print can. Oh, that scared me. Jakenzik17, thanks for the follow. And welcome to the stream. Sorry, the alerts are so loud, it scares me every time. Like, oh, scary. Whew. Okay. Anyways, going back. So it's talking about how the final type of main is IO, because, well, we're dealing with outputting stuff and inputting stuff as well. So print can take in input and then returns an IO. So if I do T on print, it says that anything that implies that is showable can be received, and then it'll just somehow convert it into an IO. So yeah, that's essentially what it is trying to do. And you can see over here that bool, there's like a bool. Wait, how do I say this? And bool is implemented for show. I don't know if I'm saying that right. Basically, there's an instance where there's a show bool, and which is why we're just able to print this directly without having to deal with it at all. So yeah, it looks like this. And yeah, over there. I wonder if I tried to remove the syntactic sugar, how would that look like? So let's say I use a monad instead. I don't know if I can. I haven't. Wait, IO is a monad, so IO actions can be combined with either using do notation or prelude this. So we can, I guess, do something like that. We have a wait, how would this work? I guess something like this. I wonder if this can be. I have no idea what I'm doing. Yeah, so I am extracting this over here, so I think this is going to be a string. And then I can do something like, and then I can wrap this back, or I could just use print. I could just do something like as palindrome str. So is this valid? So it says avoid lambda, why not? Print dot palindrome. Huh. Yeah, why not that? Cool. That's a really cool suggestion. Let's try that out. So we can get something like that. Wonder if this would work just the same way. So we're expecting to get the line from a monad, or in this case an IO monad, and that whatever the value that is in that will be extracted, and then we are going to put it through the is palindrome. So is palindrome just checks if it is a palindrome, and then we print out the result. So let's just say, for example, a taco cat. Doesn't matter what case it is, if it is a palindrome, it's going to say true. Amazing. This is so cool. And somehow it is shorter than do. I mean, I guess in terms of vertical space. We don't really have to do something like this. This one's pretty cool. So next one is non-empty strings. If we put an empty string, then it is going to. Oh yeah, that's true. We already dealt with the capitalize and also separating. So we'll try implementing those. For an empty string, if it is empty, then we can consider throwing an error. Or wait, if we do empty string, what is the expected thing? Then false. So we can just do something like this: is palindrome. If it is an empty string, then we can just say false. All we have to do is just match that. And there's also the thing where we have spaces. So we have to somehow remove it. So there's this function here called words. If we do words like taco, cat, or something like that, now we have an array of this. And then we just, so the spaces removed, we can just try to, I think there's flatten. Or what's the thing? I guess we can just append this, huh? Yeah, so we can just map through this and append it. So we can fold. That'll be our second improvement. Remove space. Remove space. So we have a string that we are going to assume has a space. Maybe remove space. And I wonder if there's a better way for this. No, I'll just try it this way, then I'll try looking for better solutions. So maybe remove space. We can do words. I'll just call it remove space. So words on that. So now we get a list of strings. We want to append this, so we're gonna put this in a fold. So I don't really know the difference between the fold L yet and fold R. Maybe I want to start looking at that now. So foldable. So we have foldable T. Then we have this over here where it receives 2 arguments and evaluates it into B. And then we have B over here, and then TAB. I guess we can do something like that. If I do fold R and fold L, then it's slightly different. This time the arguments are swapped. So I guess what is the difference? Associativity. B T A. So this is the accumulator. Accumulator. This seems to be the accumulator, and then this is the foldable. Then it returns the accumulator over here. That's why it's a different type. This one just returns the accumulator as well. And this is the value in that foldable context. Well, I can't believe I'm starting to learn. Whoa, I'm starting to learn the stuff. Excuse me. But the difference with fold L is that, it just seems to be kind of the same except this. And then instead, accumulator is in the first argument, and then the value in the context is in the second argument. I'll just read about it. There's a difference if your function isn't associative. It matters which way you bracket expressions. Excuse me. There's something stuck in my throat. Let me me see. I'm not sure if associativity matters in this case, so we can use foldr. I think. We'll try it out. So we have foldr over here, and we just want to remove the space. So you can just do something like this. So this is the accumulator, and then the element. So we're gonna do something like, so since it's the other way around, we're gonna do L and then ACK. Right? We can do something like this, and then SCR maybe. So foldr this. No, wait, I'm stupid. I'm really stupid. This should be words, str, and then something like this, yeah. This seems to be, they can, oh, we have flip, plus plus. BAB. That's a different type though, but I mean, let's just try it with this first. So we have reverse, but before that we have to remove the spaces. So we can decide to remove the spaces first and stuff, or I'll just say that this is going to be a foldable, so it's going to be a list of lists, so remove space. It's going to be a foldable T, and we can say that it's going to be T list of, so, wait, can I just do this? Right? Can't I just do that? So we have accumulator, then we, wait, can't I not extract the, wait, no, it is a, wait, yeah, this should be correct, right? So if I do something like this, so foldr, and then we have this function over here. It says I could not match car with car. Yeah. Hold on a minute. So we have words. This one turns it into a. Hi there. I was wondering where you went. Yeah, I stream every 4 in the afternoon now. Consistently been streaming at 4. So now it is a list of strings, and the thing that we want to do is, I'm really dumb. Yep, this should be L. That's, well, that was for fold. So this is the accumulator. We have the accumulator. Wait a minute, that's an accumulator, right? I need an accumulator in here. So it's just gonna be something like this, or it can be like this. So if it's foldr, we have this. This is going to be the element over here. The accumulator should be after the thing. Something like that. And we have word str cannot match type with car. Why is that car? Yeah, I guess we could just make this into this. No, this is the issue. This should actually just be a string. Not that. Hmm. Right, so now it is a list of strings, so it's something like this. That's the type. And if I try to do something like hello world, it should say that, right? I mean, that's what it should do, supposedly. Which is why we have something like this. But I think we can just simplify this to a string. We don't really care about the string. Now here's the weird part. So the actual type is a list of strings. Weird. Don't know why. Okay, well then, I hope the coding is going well. Yeah. I'm just practicing. Anyway, so foldable. But is it complaining about the... Okay, no, it should be fine. So if it's foldar, we have this. I mean, it should still work, right? Pretty sure. The accumulator is at the end over here. Then we have the thing that we're going to iterate over. So that gets placed here. And then what we did is we appended the two. So I appended this and whatever the element is over here. So now the weird part is how this is... I mean, how is that possible? Yeah, it doesn't make sense. Something doesn't make sense here. Good morning, how's it going? Hey Wakla, I'm very proud that I solved the last one. It was pretty easy, apparently. I think I was just really tired. This is what I was sketching and stuff. I was like, oh. Also, good morning. I just wanted to visualize it. And so I ended up like doing this entire thing just to get a visual on it. Yeah. This is what I ended up doing over here. After I mapped everything out, it just made sense. I was like, oh yeah, why didn't I do that? I just turned that into lists and then I appended it and then done. I don't know why. I just got really confused. I think I was just tired. uh, and now I'm just going through this over here, just in case I missed anything. Oh, also, there's this really cool thing. There's a lot of cool things. Uh, this one over here. Disregard the errors. Haskell's just one big exercise of feeling dumb after you see how easy the solution to everything are. Yeah. Solutions to everything are. Yeah, I feel it's like, oh wow, it's actually really obvious. But look, check this out. So, uh, type classes or this side over here, or was it? Yeah, they said, hey, you can do it like this, you know. But then I wanted to see if IO is just a monad, does that mean I can do something like this? And guess what? It worked. Wow. What? Wait, actually, I'll just do something like this. It just blew my mind. I was like, hey, I can work with monads and stuff. This is so cool. So rather than yeah, like just one big mind blow. Now I'm trying to figure out fold R here because I don't know. in my head it makes sense. I even tried checking the thing here. That means you understand it correctly. Congrats. Yay. Thank you, thank you, thank you. Now I can focus on all the other stuff. I always forget which fold I want to use, fold R or fold L. Yeah, lots of people, I mean, I've seen it on Twitter that they kind of uh, what's the term for it? They don't encourage using fold L because something strict evaluation or something. I'm not really sure what exactly. I'm not sure. I tried reading about it, and what I got was associativity. How fold R is from left to right. Oh wait a minute, no. Wait a minute. Yeah, left to right, and this one is right to left. Yeah. I don't know either. Could not match type car with that. So if I pick that out, since if it's fold R, so I pick that out, I extract the value A from context T, which is foldable. That's the first argument over here. So that means if it's a list of strings, the value that gets extracted is this. So I have hello, which is a string, and then I have this accumulator, which is in the last argument. So this, which is an empty string. What if I do something like this? No. And this one appends the thing. But why is it a list of strings instead? What? Okay, so cannot match type car with list of strings. Expected type is so list of strings. The actual type is this. Wait, why is that the expected type? So this is the element. I'll just say A and then ac, or maybe lm. No, L and then ac. Let's say 1 to L plus plus ac. Why is that not possible? I must be missing something really obvious here. Wait a minute. Hold on a minute. So A, B, B. B is the the accumulator, just as a string, so it has to be different. Wait, no. No, it gets evaluated. Somehow. Yeah, it changes. So I appended it. That means it's gonna be different anyway. Okay. Here's the thread on Haskell subreddit. Okay, let me check it out. Wait. The issue I have now is I forgot which one is the right one and which one's the left. Yeah, it gets... It is pretty confusing. Whoop. Wait, how do I use this? Reddit.com. Wait, is it not like this? R Haskell. Wait, what is the format like? Oh, comments. Whoops. Okay, does posting the full link work? No, it got censored. Ever since I added the stream bot. But the chat bot is just so convenient that I can't remove it. Nuke Pangea. Hold on. To have a way to add up all the numbers of all the people on the list. To explain why fold R works on infinite lists, but fold L doesn't. But my analogy is confusing me more. Yeah, let me just zoom in a little bit. With your example of an infinite line of people, the most important question is who do you get the final answer from? So fold R function gets the final answer from the first person in line, while fold L gets from the last. Because of the associativity. Okay, in infinite line there's no last person, so fold L never gets an answer. Okay. How does fold R get the answer? Like, where does it know where to start? If it's an infinite list. Huh. But that's now how, oh wait, I think, how can the first person get an answer before? It's not an excellent answer, but it gets the intuition. Go to the Stack Overflow. I think it'll be a bit clearer. Stack Overflow. Wait, does it link a Stack Overflow? Oh, the tab you have open. Oh, okay, okay. Wait, I want to read a bit more. So you might not. How can the person get the answer before everyone? So first person and last person. Fold R is the first person. So the former fold R is equal to this. So it starts here. And then we get our final answer from this. So it goes in this direction. And the latter is here, where we get from the last person. I've looked at this exact diagram so many Kale Gibbard. So we have a list 1, 2, 3, 4, 5. Okay, so fold L starts from this and ends with the last person. Yeah, then here it starts from the wait a minute. Hold on, wait, no. So the first person has to answer. Oh yeah, so it's here. Wait. I start with Z? Do I start with Z? Wait, what's Z here? Here and then bam, right? Or this diagram is pretty confusing. Initial accumulator. Oh, okay. So from last to the first for fold R, and the other way around for this. From last to first fold R, then first to last. Initial, okay. So, I think this should work then. If it's from first, I don't know, from last to first. So, something like this. But, okay. So this one gives me a list of strings. Oh, wait, okay, I know why. So the reason why is because it's expecting a list of strings instead. Rather than... And what I'm doing here is I'm returning a string. That's why. What's up, little corpse? Hey, I'm not little. Hey, Max, how's it going? So that's why it doesn't work. Because it's expecting a list of strings. And what I'm giving it is just a string. Okay, makes sense. Makes sense. So maybe what I'm looking for is something else. Cause this one can't be done. Oh, I think it's on words. Oh wait, this is not elixir. Wait. So I can just say, wait, what am I trying to do here? I can just do words and then unwords after. Yeah. Words. Oh wait, there was another one that didn't. Online. Was it? Dang it, elixir, damn it. Onlines. So it's onlines. Hey, world. Oh, it adds new lines instead. Oh, it's concat. Oh, whoops. So it adds new lines. Well, okay, that makes sense. So it puts back the line character, the new line character. So it's this. Concat. Dang it, that's what I was looking for. Concat. Hello. Here I was trying to manually implement it. Yeah, that was exactly what I'm looking for. Okay, so I have to fix this one. Yeah, remove space, which gets reversed. What if I do this? Huh. So if I try this, main, if I try espalindrum, if I try something like taco space, then capitalize cat. Oh. Oh, okay, I know why. I'll just say processed string. Now I can change remove space to be point free to be a real TM Haskell coder. What do you mean point free? Oh wait, well, yeah, what does that mean? Oh. Oh yeah, I can use the ETA reduce thingy. You know, sometimes I still get mixed up with this, the composition, and this. So I have to read more about it. I think type classes further explains it. Let's call this new SDR because epic Haskell time. Howdy do. Hey Calcium. Hi. Gonna have dinner. Bye bye. Alright, see ya. Thanks for stopping by. You can fix your understanding of point by reading it as following. So concat, the following concat is words, or following words is concat. I guess the other way around. So following words is concat. Concat following words. Oh right, following. Yeah, I need English. I need some English lessons. I need English lessons. No. Concat following words. So yeah, concat happens after words. Okay, that makes sense. So what about this then? Okay, I guess this one is where you have to specify the argument and stuff. So we'll do. And then this can just be USCR. Do main. So taco space capitalized cat should say true. Can this be? Can I do this? Oh, I guess I can. Main taco cat. No, okay, that's pretty cool. What else? What was the thing? Non-empty strings. So we've already done empty strings. I keep seeing Rust on Twitch with a ton of viewers, but it's the game and not the language. Pepe hands. Aww. Which is kind of sad. Yeah, but I think he streams game dev. So maybe his viewers are game dev people, or I don't know. Hey, amazing. How's it going? Your routine stop by. He does tons of stuff networking and random programs. Oh, okay. So I guess when we watched him, it just so happened that he was doing game dev. That's pretty cool. So you can also do an empty string as palindrome, so we can do empty, so it should say false. According to this. So they want me to use maybe. So in case it is empty here, we'll just return nothing. Because there's nothing to palindromize or whatever you call it. So this should be just. Palindromize. So it's gonna print out just and then true. I think they eventually extract it though. Oh, they don't. Okay. Testing the new PogChamp. Hey, I like what they did with it. It just cycles through the PogChamps. All the different PogChamps. So cool. Is it based on what time zone is it based on? This exercise solution, verbose, string. The first thing you want to do is apply the palindrome testing function. We want to do that in the case. Okay, so they want me to add that. Wait, I thought that. Wait. Oh, I didn't know that it showed the exercise here. Oh no, I got spoiled. No. Forget. I guess America? Huh. What time is it in America? Time now, America. 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 So what is this? Is this in the evening? Oh, wait, this is military time, so it's morning. Oh. It has 11 time zones? Oh dear lord. Okay. My time zone is UTC plus 8. Or GMT plus 8. I'm somewhere in Asia. Somewhere. Ow. What about you guys? Europe? I think costume was you were in EU or something? Ireland. I'm in UTC plus 1. Oh wow. Okay, let's try verbose. Man, living in the EU is pretty cool. You got to travel to different countries without, you know, any restrictions. That's like the best part of it. So if ever you want to travel, or if you like traveling, you can just go wherever. That's such a nice thing. And you can work in different countries as well. Man, so cool. Well, not now with Corona. Yeah. well, yeah. But usually, before the Rona, it's going to take the word input. Ultimately, this word will come from getLine. Apply the non-empty palindrome to it and match the 3 possible outcomes of non-empty pal. Americans say they can travel 12 hours by car and not change state, and they can pass through 5 countries in that time. Yeah, America's really big. So big. I was considering going to EU for. Claw is a Polish name though, but I stole it. Oh no, the name thief. Claw. So I guess I received a string input, and then the whatever you call it after. So verbose string. STR. All I have to do is do case is palindrome of str of, and we have a bunch of stuff here. No, I never knew McClaw was a mathematician. I guess I am uncultured. So if it's nothing, I'll just say is palindrome. You need to output. You need to input something, or can't be. It's apparently pronounced Vatswav? Oh, that means I've been butchering your name then. Wait, let's try it. Not amazing. Oh, okay, rating with okay, it's a test. So let me see. Wacław. So it's Polish. Let me try Google translating this. Oh, whoopsies. I was moving the wire around. Hey, let me try something. Let me see. So Polish, right? Translate.google.com.
Wacław Sierpiński.
Oh wait, no, this is not Polish. This is English. Polish. Wait, did you guys hear that? What?
Wacław Sierpiński. Wacław Sierpiński.
Wacław Sierpiński.
Wacław Sierpiński.
Wacław Sierpiński. So Wacław. Okay. Okay, I think it's pronounceable. Wacław. I don't know, I pronounce it like English school. Same. It's so it means I can just put sterling on for boats. Yeah, something like this. Wacław Sierpiński. Okay, I'll try taco cat. It's a palindrome. I'll try main again. I'll make it empty. I'll say can't be empty. If I do a non-palindrome, like Vaclav. Not a palindrome. Okay. Yep. Capital problem. Yep, we've already done that. So with mom, main, mom, it's a palindrome. Oh. Yeah, there's a tool over there. And we ended up mapping. Yep. Oh. Yep, okay. To do something in the first element of the list, we apply func. Yeah. Oh, he's implementing their own my map. Yep. Okay, so inspect the type of map function that comes from prelude. What's the difference between the type my map function that we wrote and the standard map definition? Could we use my map in the all lowercase? Okay, what was the MyMap definition here? So it's a function list. And we have first and rest, so those pattern matched. And we apply first or the head on the func. And then we recurse through the rest of the stuff. So I mean, it should be similar. I mean, it should be. Yep. Pretty sure it should be similar. I know it's exactly the same. In this segment, we'll learn how to solve computer science the taco cat problem. Wait, what? Without spaces. No, it's a punctuation also. All sorts of spaces and punctuation in there, and we have to be able to look past it. Oh, that's inconvenient. So this is a palindrome. Madame, I'm Adam. No, they wrote their own filter also. Is alpha. So I guess this is what we're looking for. One nice thing I have going for my NeoVim config is the Google integration. Whoa, that's super convenient. I don't think there's an equivalent for VS Code. Oh. Wait, how do I use this then? Features. Let me see. Oh, it's not maintained anymore. You'll definitely need a local install of Hugo. And you'll need to run the Hugo build. It's very simple. Oh, is that what he did for yours also? Oh, it's not stable yet. Bummer. It's last updated a long time ago. No. Doesn't install instructions. Yeah, I think I have to streamline a lot of things. Oh wait, where am I? Right here. I still have to get used to using Google though. Sometimes I just end up using Google, but I was like, oh wait, yeah, Google exists. Remove. I think I can use remove non-alpha. Or, yeah. Very nice thing you can do as well. When you're on a Google is godsend. Yeah, I can see how useful it is. Good thing type definitions exist. So wait, let me try using Hackage. So I'll go over here and then I'll just go through some source code. Oh wait a sec. This is the. Let me try docs, right? So over here and then I'll press S. S. Wait, am I in the right one, or should I be in the? Here. Oh, here. Search and package by name. So what was that? Car. Yeah, it's a bit slow. Or maybe it's just my laptop. Wait a sec. But I have 32 gigs. It should be fine, right? Megaparsec. Let me try megaparsec. Megaparsec. Oh yeah, because base is massive. Why is the rating so low? What's the... Is this supposed to be 5 stars? Why is it so low? What do I search for? What is over here? Oh, it's out of 3. Oh, okay. Oh yeah, it's much faster. Cool. Oh, it's such a useful feature. It is. Anyway, I'm gonna get some food back soon. Alright. See you later. So maybe this is gonna work. So what is the thing? Madame, I'm Adam! Exclamation point. Yeah, it's a palindrome. Oh, yeah, so it works. So we, dang, okay, cool. Recap. Is palindrome, yep, non-empty, verbose, ignoring case, I just use to lower and everything here. And I remove the non-alphabetical characters. And then, yeah. This way I just have one function. Naming. Right. It's palindrome. And this one is. What do you mean by grouping? Oh, like. Oh, okay. I mean, I grouped it similarly, just the other way around. Preferred J was from my previous thing. I don't think I should have done that there, but previous. Call this function as palindrome because it was our first attempt at defining what a palindrome is. So we subsequently changed our mind about what it is, and we decided that this simple test wasn't good enough. Yes. So it became this, and then oh, they extracted it. Its own reverse. Oh, okay. Hold on a sec. Where? Wait, where? What? Where is it? Then each place is palindrome appears is used elsewhere in the code. We just replace it with a new name its own reverse. So, oh, he separated it into a. Hey, let me try that. Pal HS. So this is palindrome. Maybe bool? It's on reverse. So this imports the entire pal module, but we only need this palindrome. True. So we have this is palindrome. So compiles, for suspicion is the one link between these two modules. So function composition. So ISO in reverse, normalize. Also, okay, misplunging, reject empty. Oh, this sounds more of an organization then. Whoa. Okay. I'm gonna get some snacks. BRB. I wanna munch on some food. I'm back. Oh, that was yummy. What is this? Do they show the entire file here? Where is the entire file? So I guess it starts with is palindrome. So is palindrome and then non-empty pal. Just a maybe, so if it's empty then it's nothing. And then otherwise it's just that. Just what this receives. Okay. Why is there another maybe here? Oh no, there's only two. This one reverse, reject empty, normalize. So normalize, reject empty, and but then there's no point normalizing something if it's empty anyway, right? So why not just reject it outright? So normalize here is, where's normalize? What did they say normalize does? Normalize. So removes spaces, removes punctuation, and okay, so that is essentially what the remove non-alpha is. So I guess I'll rename this. I still think it would be a better idea if I would just do normalize first and then before I do anything with it. Oh wait, no, check if it's empty first before I normalize it, which is why I had this thing here, so that if it's empty then it's not a palindrome. I mean, it's just fine. I mean, it's not that cluttered, at least compared to this. But then again, they wrote their own stuff, a lot of it, so. Well. Folds. So, filter versus fold. Consider a case where we might need to reject string inputs that have spaces in them rather than simply removing space. For example, many websites don't. Did you put spaces in the middle of, say, your first name? Yep, fold has an accumulator. Filter just filters the existing thing. Maybe a string? What? Why maybe? Reject non-alphabetic string. We have case where my all. What's my all? Take its first argument, a predicate, since we want to test whether all characters are alphabetic, and we'll use is alpha from the data car module. Why is... Oh, because it's probably wait, there's a thing called all? Apparently. So I guess I have to change this then. I'll do okay, so if it's nothing, then that means it found a thing there. So I guess I'll change this from normalize to reject. So I'll reject non-alphabetical stuff where we have string and then maybe string over here. And then all I have to do then is just do all is alpha on this. So except it's complaining because cannot match type bool with maybe string. Right, I have to case this. Hey Justo, hello. So if it's true, then that means I can just say just. And then, right, so I need str. Just str. If it's false, then I'll say nothing. All is alpha. Why not if all is alpha, then... Oh yeah, I guess I could do that. If all is alpha, then we want just str, else nothing. And there's a problem with this one, because we have to add str. Yep, so something like this. Oh wait, no, sorry, whoops. How's it going? I solved the... I'm just checking this out, just in case there's more stuff to the thing. But I've already solved the... Wait, no, not that. I think it was learn for Haskell. I've already solved everything. Hooray! Oh wait, no, not this. There's always more stuff, yeah. I solved it, yay! I got stuck yesterday on the tree to list, and I thought, wait, why am I making a big deal about it? So I just appended the left and the right, and then yeah, and I placed it in a list. And there, it just worked. After I want to, after type classes, I'll probably try Advent of Code. But I'm kind of scared because I haven't read this at all, and it seems pretty long. But maybe I want to solve this. Did you do many different types of functors? It was only three. Whoops, not this one. Oh, wait. Yeah, not this one. Where's the other thing? Oh, I just closed it. Okay. That was for the tree over here, which is this, just this. And then there was also for list, the custom list type, and then and there's one more thing. Instance, functor. Oh, also for secret. So secret and then list. Yeah, actually just three. So I don't really know if it's many. Shadows in existing binding. Oh, I should probably replace this then, huh? Right. H and T. Yeah, mostly. A shadows existing binding. Bound at 636. Oh, because of... Might enjoy solving this one. Whoa! Whoa, what is that? Wait, can I not check the... So if it's this, then the... So that means it's this. Okay, yeah. What? Functions themselves are types and values. Whoa. Wait. I guess I can put it here. I'll do this later. I'm gonna try solving this. Duplicate instance declaration. Oh, it already exists. How do I implement my own? So I see this a lot, A to B, but it's actually... Oh. Oh wait, how do I... So I can't, right? If it's that, so pure and no, not pure even. Oh, whoops. How do you remember all of these language extensions? That's a lot of them. Instance signatures. Instance six. Unterminated. What? Wait, how's this unterminated? Am I blind? Language instance 6. I mean, for this it's fine. Hold on a sec. Instance 6. No implicit prelude, scope type variables, language. Yeah, I don't think I misspelled any of these. You might not need. Need what? Wait, what's that? It just shows me emojis. uh, what is this about? Wait, did I write it down right? Language, no implicit prelude, language, scope type variable. So both of them ends in the in that yeah. So it should work. It's complaining about something. How did coining do things? Pretty sure they use language extensions also, but so hey, they use this. What flavor of Haskell are you using? Flavor. There are Haskell flavors. This is the version I'm using. Pretty sure it's... I'm so confused. Yeah, it still seems to be the same thing. Or maybe this is just a bug. Or from here. Let me delete this. Nah, doesn't seem like it. Maybe it's just broken. Yeah, so I have like... Yeah, maybe it's just broken. Wait, give me a bit. Super weird. No. Okay, I'm not so sure if it's an ID thing. Cause if I do, maybe if I do, yeah, it works fine. So maybe it's an ID thing. Weird. That looks super weird. Whoa. Non-scope type constructor or class functor? Oh, do I have to import functor? Is this, where does functor come from? Import. Oh, yeah, the ID is dead. Where does functor come from? Wait, I can Google this. Google Haskell.org data dot or something. It doesn't say where. From base prelude. Do I import base like I would import anything like that? Or how do I import prelude? Selectively. Protolude. What's a protolude? Oh, it's a capital. Prelude. Functor? And will that work? Dun, 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 dun. Oh wait, no, I don't think it works like this. I don't know how to import the thing. Data.functor. Oh, it's my fault for turning off prelude. Oh. Oh wait, it looks like data.functor. Let me try data.functor. Data dot. Is this even the right one? Yeah. looks like it. I hate the how the ID is broken. Dang it. Come on, man. Why are you broken? I guess it's fine now. Yes, it works. I think HLS. Yeah, restart the OSP. It's just there. So I'll just restart it next time. Duplicate instance declaration. Oh, wait. This is gonna be hard. Like, how do I exclude this specific instance? I guess I could copy how they did a functor here. So I can just copy the type class itself. But this is weird. How do I even use this? Functions. All over the place that you may forget it's an actual type itself, since functions are first class values and types. Oh, so arrow is a type also. Oh. Take the function even. What type is it? Num2 bool. Wait, is it num or is it integer specifically? It takes in a number and then a boolean returns a boolean. Functor. Wait, I just want to look for the definition, so I'll just copy this. Let's just say n to be lazy. Oh, okay. Okay, this is gonna be a massive pain. No, that's gonna be hard. Also, arrow is a context also. Huh. Not too different from either type, either int bool. Yeah, yeah. function is a polymorphic type, just like maybe. So if it's, wait, if I do foo, and then let's say A, B, C. Just for convenience, we put the constructor name, arrow, infix. Okay. So in Haskell, functions are just take receive something and then return something. If that's the case, since it takes two type parameters for. Oh, so this is a function. So receives A, returns B, and then another function here that receives B and returns C. Well, that's why you can partially apply stuff. Three argument function foo arrow bc. Whoa. All functions take one argument. The rest is curry and sugar syntax. Yeah, that would actually be kind of confusing if there was none of this. It would make it even more unapproachable. Well, I never knew that. Huh. So lambda AB is AB. So is it fine? Is that really why curry works in the first place? Ah, okay. AB's. Yeah, that makes a lot of sense now. So the lambda A returns another function. If assuming it's not, assuming it's just they just provide one parameter. So if I just do that, it just returns function B to C. Oh, whoa. Wait, so functors can. Oh wait. Wait, so you can use. Oh wait. Uh. functor that takes a value t and returns the value a. It treats that function as our functor fa. Oh. Then and then the oh whoa wait. Just modify that function to take t and return value b by another mapping into b function. You can modify that function to take a value t and return a value b via another mapping a to b. So function is also a container while a list holds an a. So the function returns from will return an a. Wait, should it be b? Oh wait, will return an a. Oh right, okay, t. Yeah, okay. So arrow ta. Whoops. Sorry, I thought it was ab. Got it. I never knew functors could be used for types though. I mean in a type signature level. Oh wait, no, not type signature level. But more like, wait, this is kind of blowing my mind. So you can think of a function itself as a functor, something that would return an a given t. Wait, I want to see how that is implemented. I'll try checking Google. Why is everything? Or is it something else? How do I search for this? I don't think anything is showing. Fun fact, since Haskell's lazy, lists and maybe types, etc. are actually, oh, okay, wait. Right, because it's like this and then t. Right. Extra parentheses. Oh. Maybe types, etc. are actually functions evaluated on demand anyway. In this case, from a function value producing A to a function value producing B. Oh. What? Wait, I'm kind of confused though because if so the function becomes. Oh wait, hold on. Wait. Oh wait, no, this is a type. So So this is the function itself. Let's say f map. So a b, and then in this case it's gonna be something like, oh wait, no, I'll just cross this out. So it'll be something like this: a t uh ta and tb. Yeah. TATB. Yeah. Something like this. Yeah, actually, this is fmap. Oh. Well, so ah, wait a minute. Taking a function as a functor and mapping into a new function, the detonation functor. This. So function as a functor and mapping to a new function. This is why also burrito analogies break down. Yeah, I found that a really strange analogy. Wait. Does it show on Typoclassopedia? Oh wait, I think they reviewed it. Nope, they didn't. Functor instances. Oh no, they didn't. Doesn't show on Google also. I couldn't find it. I added the parentheses. Or maybe, wait. I think it mentioned something else. Instance functor arrow t where. And I'd complained about this. So it's R. So R. Dang it. Functor list maybe IO par. Oh, it's over here. Huh? So wait a minute. F map. So it gets passed. So oh wait. So F and then B. So this is the function than a container. F plus 1 times 2. Whoa. Wait, I'm still taking a while to process it. So times 2 is the FA. Whoa, wait. My god. That's... So if it's... So this is... right, this is... int. Oh wait, it's times 2, so just this. So int to int, because we already partially applied that. And then this is, yeah, int to int. Oh, wait. Wait a sec. We just f map plus 1, just then this plus 1 times 2 is FA, then f map FG. And so this would become... Oh my brain. Oh, this is so strange. So it's like f of g. In this case it would be... Wait, sorry, this is taking me a while to process. How do you extract this though? So since it's... Yeah, wait, how... isn't it supposed to extract the value from this and then apply it to this function? So how do you extract this over here? Yeah, how do you extract that? So if it's like... If it's like this... int... Yeah, whoa. Wait, what? No, it's not this, definitely, no. Extract by applying functions to the first FA. function produces a. So the first fa function produces a. Oh, produces a. So this. So it produces this. Okay, got it. And then so then it gets applied here. So that's why this gets extracted and then applied to that. Okay, wait, let me just try to. So we have this. So it's TA. So int. And then this is int. So this is the value that gets extracted because this is f. So this part is f. And then this is a. Not blocking what it perceived as duplicates. Oh, bot? Oh, whoopsies. Sorry. I'll just apply that. Yeah, the bot's really strict. Sorry. So fmap fg is equal to t g of f of t f. Oh. G of f. So oh, so which one is, oh, it's the second one. So g of f of t, g of f of t, g of ft. Okay. And then this one is something like int to int, and this is the changed so it's a to b, and this is the a, so it's this one. I should really color stuff here instead. I'll say that this is, I'll just rewrite this. So I'll do something like this, int, and we have int over here, and then this is a, and this is f. So that means this over here gets evaluated to b, where f is applied. Oh, what? Or this applied to f. So it's something like bot blocked. Oh. Okay, here. Yeah, it flagged it as hostility. I don't know why. So weird. So it's f of g, f map of g comes that, so x, f of g of x. So x is the, wait a minute. Cg of x evaluates to a. And then gets applied to f. So it multiplies first. So then it gets applied to a. So it becomes something like wait. Still trying to. I'm almost getting it, but I'm still not quite there. Dang it. Something's still not clicking. We can do f map, then try. So plus 1 times 2. So it's integer to integer. So if I do f3, so first it times 2 and then plus, no, it's plus 1 and then, oh wait, no, it's times 2. Yeah, sorry, times 2. 6, 7. So how would, oh, so it's like that is just blowing my brain to pieces. Oh, whoa. Okay, I see now. Yeah. So plus 1 gets evaluated after this one. So it's this and then this. Oh, so that's why it's like that. So it's prefix and then f of g. Oh, wow. Wow, that is really smart. Whoa. Whoa, that's super cool. So f of gx. So it's not okay. So it's gx. So it becomes times 2 x plus 1, because this gets applied to this. So this one gets, oh, I see now. This gets applied to this, but it's still expecting a thingy here. So it's also an applicative and a monad. Oh. That makes things super weird. Wait, how is it if it's an applicative? Then that means we can do stuff like wait, so wait. If it's an applicative, oh man. So an applicative was something like, oh, that hurts my brain. So it's like a F and then A to B. So it's a F, A to B, and then, so this is something like, something like, int, and then A to B. Okay. Ooh. Start with pure. Oh, okay. So pure does this. It's pure. Yeah, so pure, we put a value into a context, which is going to be FA. So that means, assuming that F is this, where it's arrow int, or well, we can just say A, or T. Let's do T. So that's F. A is going to be over here. So it puts A over there. So, in the case of a function, so the return value, so we're setting the return value. Oh wait, no, we receive the return value and then put it here. So we're setting the return value. Okay. Setting the return value. If I do something like pure, pure, I can say something like, oh, wait. Hey Calcium, hello. Yeah, I was just walking around because I was really confused. He's telling me how to use Justo is telling me how to use the uh, trying to apply what I've learned on this one over here. On this as the context as F yeah. Yeah, and currently it's making my head hurt. What I know so far is that the return value of we have the return value here and then we apply it to this and stuff. So and that's all you can know. So how do you use it then? If okay, if it's a wait, can I even yeah, how do I do that? Unless it's something like a value ID? No, it's not ID. Cause ID is no, it's not ID. Whoa. So it just puts it in a function then. So set the return value. Now it's enough of it based on the rules. I'm gonna write it down one more time. Maybe I'll get it. So pure. And we have A to FA. And if F is it's gonna take me a while to get this. Is this T? So this sort of stands for yeah. So it's like something without anything. I don't think I can actually do anything with that. And then A is well going to be an A. So it's like you're putting the thing here. T, whatever that is. And A. This is so weird. Whoa. Whoa. So I'm returning A. I'm just putting it in a function. Yeah. So now it fits because it's a function that has one argument, but it was ignored, and it returns A. We'll talk about as functor as a value in a box. So I've waited. So pure is just putting a return in a function, and since so the so the context is a function with an argument, and pure just supplies whatever it's gonna return. It sounded better in my head. Okay, yeah. And for apply, oh, the type signature looks scary. So it's arrow T, then A to B. Okay, so that gets extracted from that. And then TA, and the TB. Yeah. So what would be a proper term then for that? Because I always thought of it as just extracting, but in this case, you're not really pulling out the. So it's something. Wait, so if it's like this one gets removed from it. Wait, so if I'll do something like, oh boy, let's say, so if this is the case, wait, let's just say it's 1. So 1. Hold on. No. No, it's A to B. So it's a function that returns a function. So I'll say times 2. So this gets. Wait, let me try. This is like some super cool stuff. So it's something like this, and then TA, huh? So it takes the a from that. So a. Yeah. Wait, how did it look like? T A to B. So the a part, the return part of it, and then. So if it's this. Oh wait, why is it just plus? Oh wait, because it's wait, yeah, why is it just a plus? Oh, because it's a thing that it's TA, so that means it's a 2-argument function. Yeah, it's a 2-argument function. Two arguments, so that's why there's times, and it applies. If you're writing out a function like this, I need a whoa. So time supplies this, and then 3 results in 39 because well, so it's 30. Oh, wait, let me try. Plus then times 3 3 Yeah, this is super unexpected. So it's plus 10. Oh wait. Cause I never knew you could use arrow like that. I always just imagined like I mean the other ones are kind of easy to imagine, like maybe uh and list and stuff. But if it's with functions, it's kind of yeah, pretty much. let me try the example again. So the applicative for apply it's this, and then arrow T A to B, T A to B, T A, and then T B. So if I think of like context, so if it's if it's something like an int to int to int, which is plus this part gets taken out, so this gets returned. That's why. Here, let me try. I'm just doing it in the other screen for now, so I can scroll up in chat. So and to and let's say, so this part over here is this part over here. And then A and then B. So if it's so the example was +10. So +10. So that means it's something like into this into int. So this is that over there. And then the final result is going to be something. So that means ten. Oh. Oh, this makes no. No. Wait, I think this just broke my brain. I'm just looking at it. I'm just trying to understand. If I use it as context, text then. Oh. So that means it's just this argument is applied somewhat. Huh. If it's just int to int, then that means it's something like a, so just b. So like the argument is b, and then somehow we have a, so a plus b. So something like that, and here it's like oh wait a sec. Oh wait, I'll use plus 10. So this one is plus 10, so we're looking for one more. There's going to be a plus 10, and then so this is the return then over here. Oh, I should use this color instead. Yeah, I should use a different color. So something like a plus b, but then somehow we only get b, because a is somewhere or something. And over here, which is, in this case, it's plus 10, so it's going to be a plus 10, more like 10 plus 8, I don't think it really matters. So a plus 10. So the final result would be, so applying these two things, so like an f of something, so like so something like this, a plus b, and then we're expecting x or something. Wait, does this make sense? No, I don't think so. Wait a second, this makes no sense. What I wrote makes no sense. Oh wait, a plus b. Wait, what is this? So if I do 3. So, oh wait, where does b come from? Oh wait, maybe. Wait a second. Hold on. So if I substitute this plus 3 plus 10. No, this one doesn't make sense. Wait, does it? Oh wait, no, wait, sorry, I'm just rambling. So it's something like this, and then a is going to be a plus 10. So if I do 3, this is going to be, so this is going to be like a 3 plus 10. Yeah. So it's something like this. Wait. Oh, my head actually hurts. Wait, let me just full screen this. So this is the thing. So rather than getting a from this, it's somehow the, wait, so I think I have to write this better. So it's something like, I guess I have to color this better also, but. So B is yeah, so, wait. So B will be provided by this over here. So this is, oh no, whoops. So B over here comes from this. So that's 10 plus 3 over here. And then that's going to be 13. Oh shoot, wait, no, this makes no sense. Oh no, wait, no, it makes sense. So A is going to be 3. So it's gonna be, yeah, 16. Wait, is it like this? I just sort of just traced it, but I don't even know. I think this part is not understandable. So I just gotta rewrite this or something. Okay, it stops there for some reason. So something like wait, I lost it. Oh yeah, assuming this is the thing that you mentioned earlier. Assuming it was this. Wait, sorry, I have no space to put it. Assuming it was plus and then apply and the plus 10. Yeah, so this is what I'm trying to trace. Oh wait, I'm almost there. Wait, I don't even know if it's something like this. Maybe more like this. But then I don't really know where A comes from, I guess. Something like this, and this will be that A plus 10 part. So if I do something like f of g of x, if I do something like this, so it'll be, wait, no. No. I mean, why would that be A, right? It should be B. It should be B. If it's A plus 10. I think I have it some other way around. I think they should maybe be B. Or no. No, it's just like this. It's just like this. I think. So there's gonna be something, and then the 3, or the thing is there, so 3. then this over here is going to be well, it's not in the book for a reason. Yeah, maybe. But I want to figure this out though. Let me see. So B accepts that. Huh. Where does A come from? It's only one argument, alright. I guess it's just. Oh, wait. Oh, wait. F of x, g of x. F of x, g of x. Yeah, if it's f of x, g of x, then x f of x, g of x. Oh, but wait. Yeah. If it's. Because that is a plus b, right? But then it only takes the. This is so weird. No, no, no. Wait, so this one is int 2int 2int, and so for this first part where it's f of a to b, then that means it only takes this section then, which is pretty weird. So it leaves that out, so it just becomes b, and then somehow it gets a from somewhere, so a plus b. So that's for the first part, and then yeah, the first int is t. Yeah, t something. Yeah. Yeah, so the first int is t. But that gets omitted. So that means it's just a function that was assumed to be partially applied already. Where the first argument is. Wait, so somehow it assumes that a has already been applied or something like that. And then for this it's plus 10, so it's int already. And then the thing so this is wait, hold on. So it's this. Oh wait. must go to bed. Oh, okay. Yeah, those I'm still kind of sad I didn't figure it out though, but it's really interesting. I wanna try to eventually get it. It was really fun. It is super challenging though. It isn't just like, you know, the ones in the exercises. Kind of forces you to actually really know. You're just trying to follow the answer, yeah. Trying to see why it is. Hoping it would click somehow. Oh god, it's already 9. Hold on. It's actually really late. So it's around midnight for you, right? That can corrupt in it. But it reinforces that these functors are a set of rules and laws that can corrupt in many situations, not just boxy data. Yeah. Yeah, like right now I'm not sure how to even think of it, cuz I tried using how I imagine it to be, and it just doesn't work. That's why I'm not really getting it. They pop back up in stream processing, parsing, etc. Yeah, hopefully I'll get to encounter these kinds of problems, because it's actually really interesting. I'll try this. I'll try I'll try thinking of for the applicative and functor monad, a whole family tree of them. Yeah, I saw the weird ones like so many different kinds of monads, like IO, and at one point I saw a free monad. I don't know what a free monad is, but and there's yeah, I saw all sorts of things. There's even applicative do. I don't even know what those are yet. Not just kinds of monads. Oh, huh. I see. Is it the in the repo that you sent? Did it? Does it cover it? The one you guys use for training and stuff. Oh wait, right. You might want to DM that instead, cause it's gonna block it. The chatbot's just gonna censor it. Oh, it's not like okay. This one did me in when I started contra map be a what? What? Wait, how is that possible? Huh? How? Whoa. Whoa, what is that? Yeah, I won't try it now. I don't even know the other things yet. Alright, I'll try to remember this. I have it saved in the VOD anyway, so I can look back to this. Yeah, I'll try sleeping on this, and then I'll see if I'll get it tomorrow. Or maybe I can do more reading about the thing that you sent. So maybe I'll be able to change how I think about the 3 type classes. I can't remember if RO is in that repo. Aw. Well, I'm just gonna have to keep trying. I think you should sleep, man. I think it's pretty late in where you are right now. It's like 12:30. Whoa, dude, you should sleep. I'm doing well. Well. You can skip learning it all to make programs. Only learn for the fun of it. Yeah. I mean, I like doing both. Yeah, but I can definitely see why. Like what you mentioned before, where you don't need to know category theory to use Haskell for work and stuff, but it can be used as a supplemental sort of thing to help you gain the intuition for it. I think I have to brush up on my discrete math though before I do any harder theories. Balance is good. There's actually hundreds of categories, but not all equally dominant. Yeah, and the whole category theory still confuses me. But I guess I haven't really read much of it yet. But I have plans. Yeah, that's true. Yeah. Have a good weekend. Hey, you too, man. Thanks for the exercise. I mean, my brain is strained, but it was fun. Yeah, I'm gonna try to figure it out. Say good night, dude. It's really late for you. Thanks for the help and for the explanations. Happy to bring the brain strain. Alright, see ya, man. I guess I'll just end the stream here, since it's also late for me.